Hello, and welcome to another episode of Hacking with Friends. My name is Cody Kinsey. I am a security researcher at Varonis, and today I have on a special co-host, ethical hacker Alex Lynd, who's come on to show us a little bit about Wardriving. Alex, thanks for coming on the show today.
Of course, thanks for having me.
So today we're going to be focusing on what you can do with Wardriving data. Now, Wardriving has been around for a really long time. It is nothing new. And in the past, people were able to drive, bike, or walk around and usually have a laptop that was collecting wireless signals as well as a GPS, which when combined could actually map the location of wireless access points all around. Now, it's kind of funny because smartphones actually do this all the time and send data back to Google, for example, in order for them to be able to do geolocation. So by having a giant network of all these Wi-Fi networks that are geolocated, they can tell roughly where you are at any given time. So this data is actually really useful and you can do a lot with it. And one example project that Alex actually did himself, which was really cool, was the Creep Detector. Now, what the Creep Detector does is allows you to detect whether someone is following you that has something like a cell phone or another Wi-Fi device that is putting out a signal that we can track. So today we're going to show off an advanced example, the Creep Detector, that actually allows you to find potential stalkers that are following you, and a couple really basic examples of what you can do with Wardriving and how cool it is to do this thing that's frankly been around for a really long time. So Alex, for somebody who's like a complete beginner, how would you describe Wardriving?
Wardriving is essentially when you're moving around, like say in a car or walking, and you're just mapping using a device that scans wireless networks and devices around you. And it can plot this information to a map. So later on you can survey, say where the devices you spotted are located at, and you can pull in various information about them afterwards.
Right. So when we are using something like maybe an Android phone, we are pretty locked down in terms of what we have access to. But there are still some options for us if we want to get into Wardriving. Now, one of my favorite things to use is just an old Android phone because there's an app called Wiggle Wi-Fi that allows us to run this, download our own data sets and basically map all of these different access points and then export a CSV file that is really easy to work with. In fact, it's so easy to work with, we can map these access points incredibly simply just by going to a URL that's part of a custom Google Maps system. So by going to Google Maps, uploading this CSV file, we can geolocate a lot of different devices. And this could be a lot of stuff. This could be IoT devices that are creating their own access point. This could be Wi-Fi cameras. This could be printers. This could be lots and lots of different things that you detect when you are walking around with your Android device. So Alex, are there any other data sources for Wardriving data besides Wiggle Wi-Fi?
Could you say that again? I heard you address me.
Oh yeah, I said, so are there any other data sources for Wardriving aside from Wiggle Wi-Fi?
Oh yeah, there's plenty. So one of them, a Linux utility that we can run like on a Raspberry Pi or a laptop, and we can use that to survey places that we're Wardriving around, for example. Or there's even one that I wrote for the ESP8266, which you can run like through the Arduino IDE, and you can parse over Arduino CLI or to an SD card that you can later pop open a CSV into Wiggle with.
Definitely. So there's not just one way of doing this. If you want to run your own custom ESP8266 setup where you can just add a GPS sensor and then start logging networks, that is something you can do and write to an SD card. Or if you want to, you can also have a Raspberry Pi running Kismet and get even more data. And what's kind of cool about this is that Kismet allows you to see not just the access points that you're passing by, but it also allows you to see the clients. So this is random devices that are connected to networks. You can basically analyze the relationship between, what device is connected to what network. maybe really, really popular networks with lots of people connected, the amount of information you get back is really intense. But the data is also a bit harder to work with, as we found out when we were trying to do the Creep Detector project, because there's a lot of different fields, the format is kind of funky, and frankly, it's a little bit of work to get used to it when you're working with this kind of data. So that's what we want to explore a little bit today, just showing you the different options that you have for working with this data and how you can get started with doing it. So first off, Alex, what would you say is probably the simplest way to get started doing Wardriving, or being able to just map the location of wireless devices around you?
I would say definitely Wiggle, because the interface is pretty intuitive. You can launch it from a smartphone app. But if you want a more hands-on version, probably the custom one that I'm working with on the ESP8266. I'm trying to build a platform that anyone can have like plug-and-play software modules, all sorts of fancy stuff with. But besides those.
Yeah, so I would agree with that. For the average user, getting their hands on an old Android phone is probably the easiest way to do this. So let's go ahead and go over to my screen, and we'll start talking about the way that we can get at these data sources. So if you go to wiggle.net and you go ahead and sign up for an account, then you will be able to keep track of all of the stuff that you have uploaded. But this is actually not the easiest way to get at these files. So some of these you can see are .csv files. That is good. But some of these, when we download them, will not be in the same format. They've basically been processed by Wiggle, and suddenly they're in some format that we have to adapt. So if I try to download this one, I believe it's going to download as like a KML file. Yeah, so it wants to download as a KML file. And KML files, as Alex and I know, are trash to work with. They are very annoying. So if we want to export this data and we want to do it in a really simple way, I mean, this is going to keep track of it. And like, yes, we can change it over. And this is also very useful if we want to just see how much information we've uploaded to Wiggle Wi-Fi and maybe see like a really good capture. If we want to go back and recreate it, we can do that. But by far the easiest way to do this is to go into your app on an Android phone, on Wiggle, and just export as CSV. And it will literally just kick out a CSV file that is formatted like a little weird, but it will give you the information that you need to just easily export this stuff and start to do just basic things with it. So if I wanted to, for example, take this information and export it to a CSV file, I can open this in, well, for one thing, I can just open it in like Numbers, like the default program that macOS opens things in, and it opens like this. So if I go all the way to the top, I can see when I get a file from Wiggle Wi-Fi, the header is a little bit of a problem. This is actually information that's included in order to tell us, which version of Wiggle Wi-Fi, the model of phone that was used, just all this extra information. You can see this was a Samsung phone. And while this is interesting information, it's actually not the proper header for this file. So when we're starting to play with this data and we're starting to work with it, then we need to be mindful that there's actually a second, it's line number 2, that is the index that has the key for all the rest of this data. Whereas if we were to look over here, then, this is not really going to give us much information, but we can open it in Numbers and see what the correlation is. So if I open this in something else and it starts popping up and saying, hey, which one of these columns is correct for longitude or latitude? I can be like, okay, well, this is annoying, but I can see right here, the board equals whatever, that is current latitude. So this is kind of putting a Band-Aid on the problem. Like, really, once we get into working with something a bit more advanced, like Google Colab, then we'll be able to filter this data and play with it a little bit more. Now, Alex, for somebody who's never heard of Google Colab, could you describe it?
Yeah, if you've ever heard of Jupyter Notebooks, it's basically an environment that you can run Python in, but it allows you to visualize various forms of data. So for instance, you can map things, you can have data tables, graphs, all sorts of fancy features. And Google Collab is a platform that allows you to run these Jupyter Notebooks in a collaborative environment that other people can look at your code at online, basically kind of like Google Docs, except for visual code in Python.
Cool. Yeah. I mean, that's a very eloquent description of what it is. So if you have ever used uh, just a Jupyter notebook, then a notebook is basically a really visual interface that is presented through a web browser. So you start out by just launching this in code, and then you move on over to a web browser that allows you to easily input Python code and get a result back. So this is a very, I would say, a very easy to organize coding projects and sharing them with other people. You can even export a file you can just upload to GitHub, and other people can run your code in boxes and make sure that your code actually works with the right data. So for me and Alex, we were trying to find out ways that we could basically make this really easy for other people to copy. And the best way of doing that in some cases is exporting a Jupyter Notebook file where people can add their own data. And when we're doing stuff that's applicable to, Wiggle Wi-Fi, you can just put your own data into this code, run it, and it should work the same way. So Alex actually showed me this because I didn't know this, but if you go to Google Maps and create a custom map, then you can upload a CSV file, which is really, really cool. So yeah, if I want to actually enable this, then at a certain point it cuts you off, but by just uploading this CSV file, do I just add a layer? I actually don't even remember how to do this. Oh yeah, import. So if I want to import a file, then I can drop a CSV file here, which is what I did. And once it finishes loading, then you get this. So what is this? Well, if I click, then it gives me the information from the from this entry in the CSV file. So this row is now represented. I can see the that errant index that's just telling me about the model of phone that this was recorded on, and the version of Wiggle Wi-Fi is still here, kind of polluting our results. But we can see the basic stuff that we're looking for. So we can see the MAC address of this wireless network. We can see the security of it. We can see when it was recorded. We can see the longitude. We can see the latitude. So, okay, that's helpful. There's other things that would be more helpful. Oh, and we can also see the SSID. That's very useful. So we can click around, and we can basically, if we want to, see where I went with my phone happily were driving away. And you can see even, I think I was driving, and you can see the exact interval. It would scan every X amount of seconds, and you'll get a little cluster that pops up of networks that were identified in this area. So I can see here AT&T Mobility. I can see whatever this is, Abraham Lincoln, nice. And this is how we can get started importing this data. So I think, or at least I hope, that I have one of these data files up. No, I don't. Wiggle.csv. So what I'm going to do is I'm going to go to Wiggle, and I'm going to take one of these files. Let's just say this one. And I'm going to just drop this in to show you guys what it's like to add your own data. So let's say that you were on Wiggle Wi-Fi, you have taken your own data set, and you want to add it. So I'm going to remove this one. I'm going to try to import it. And I just want to show you what it actually looks like, because there's an additional step of cleaning up this data. Alex straight up just deleted that top row, which I commend him for being innovative. That is one way to clean up the data. But in this case, because we're offset by one row, what we can do to just place our stuff and be able to work with it quickly is we can take a look at the data in our other program, numbers or whatever we have that opens up CSV files, and we can just correspond. Because this is asking us, choose the columns to position your place marks. Like, where does this go? What's the geolocation? And if we want to look at these last two, board equals whatever, brand equals Samsung. When we go over to our data, we can see board equals whatever, brand equals Samsung. One of these is longitude, one of them is latitude. So the Samsung one equals longitude. So if we click on that, it'll ask us longitude or latitude. Longitude. This one will then be latitude. And then it'll ask us what's the label going to be, like what column should we get that from? And we probably want the SSID, so we'll go to the app. We can see the label's app release. Again, this isn't pretty, but I'm getting you guys started fast. So here we go. Boom. It's going to load the layer. It's going to parse it. It's going to call Google. It's going to tell on us or whatever. And then it's going to come back with some information about where these wireless networks were. Now, this is also, I believe, a massive file. So one thing you should be aware of is that this will cut off the number of results at a certain point. I Okay, here. Whoa. Okay, so wow, we see that there's a lot here. In this case, we were able to track motion from East Hollywood all the way to La Brea. And you can see I was happily war driving along during some sort of ride along Beverly Boulevard. So this is as much tracking my motions and where I was as the wireless networks I was able to see at the time. But again, if I want to know what someone would see if they were at this restaurant, I can click right here and I can know that they will probably see Untitled. Well, that's not encouraging. Oh, there we go. Okay, so some of these don't have SSIDs for some reason in this area. We can see AT&T Mobility. We can see a Lime scooter of some sort, maybe? I don't know. Who knows? But we can start to see different SSIDs that are displayed. And some of these also, oh, I know. So some of these were not displaying any information about whether this was a Wi-Fi network or if it was something else. So Alex, I forgot to mention that this also does Bluetooth as well. So yeah, so if we were driving along here and we see something like Bluetooth wise, in this case, if I'm clicking on it and I don't see anything, it's probably because Google Maps is plotting a Bluetooth network. And when I'm like, hey, what's the Wi-Fi network name of this Bluetooth network? It's like, are you stupid? Of course, it doesn't have one. So one of the steps we can do when we actually get into our notebook is we can start trying to change this around so that we get rid of stuff that's not related to Bluetooth. And I want to show off just very basically what Collab is and what it looks like. So I'm going to switch over to that, this one. Okay, so this is Google Collabs, collab.research.google.com, although you can just Google Collab, and they're really good about getting you over to this. So this is what my project looks like right now. It's already run, but maybe I want to make a new one, a new notebook. And let's start this from scratch, and I'm going to have to give it permission to run, and hopefully I can show you guys what it looks like to take some of this data that you can just generate on your cell phone and start importing it. So first, I need to literally import it. So I need to actually be able to upload something so that I can access the data. So we're going to take the same file that we were just working with, and we're just going to drop it here. Did I full screen this? Of course I did. Why? I'm going to unscreen that, full screen this. And let's now upload a file. By the way, literally Alex Lynd just taught me how to do this. So I'm acting like I know what I'm doing, but like, all right. Wait, no, I don't want to be in this folder. Was I already in that folder the whole time? I don't know. Go back, undo. What? Okay, fine. So I'm going to upload. I'm going to just go right here and I'm just going to drop this. And I'm going to press enter. Cool. I'm going to press OK. And it's going to upload. And now it's put it at some like random place in the file system, but whatever, I don't care. I'm going to right mouse click, copy path. And this is what I need now to reference it. So if I want to reference this in the code, this is where this file lives. So that's how easy it is to just take something that we've generated on our phone on the Wiggle Wi-Fi app and then upload it to Google Colab. So now I can start messing with this file. So I'm just going to copy my code from this other side that I was working on and bring it over here and go over what it's doing line by line. So first, we're going to import Python pandas, and this is going to allow us to start editing and playing with the data as a pandas, or what is the data type in pandas? I forget. I'm already forgetting. A data frame. Thank you. Yeah, exactly. Yeah, so it's going to make a data frame, and that allows us to start slicing and dicing this in different ways that are really simple to do in Python. So if you're a beginner with Python and you just want to start playing with this and doing some analysis, I mean, the kind of stuff you can do with this is really, really cool. I mean, you can start looking for maybe everything of the same manufacturer. You can start looking for everything with the same network name. Or something close to the same network name. You really can write your own custom filters to bring in data, which is awesome. So here, I'm going to need to specify the file I want to work with. So I'm going to right mouse click. I'm going to copy path again and paste it in here. And I'm going to run it. And what I've done is I've created a data frame that's just called df because I'm very creative. I've set the delimiter as a comma. So sometimes you'll have a file that's separated by something other than a comma, and you can like specify that here and make sure that you're actually grabbing the right character to separate everything. Our encoding is Latin 1, and then our header is 1. So the header being 1 means the header is not 0. And that means that we're ignoring the 0 column that has all this information about like the program that and like the program version and the device it ran on, and instead we're selecting the second, or technically 1, but we're ignoring 0 and going straight to 1 that has the information we do need. So this is where we're basically fixing where we had this extra line of information that's messing up our results. So as soon as this runs, which I think I already ran it, but why not again, then we should have this data frame. And if I want to start just sampling it or looking at the information, I can do that really simply. So I'm going to make a new code box. I'm going to run df.sample10. And there we go. So Alex, do you know what the .sample command does?
Yeah, I think it just takes a sample out of the selected CSV file, correct?
Exactly. So this is just taking a random sample of just like some 10 networks. And I could do this for, 100 networks too. This is just basically me confirming that I've taken this information, I put it into a data frame, and it's coming out. So I can also see that there's probably some stuff that would need to be cleaned. When I have like a nan here, that's not good. That could potentially cause problems later on because this is like a null value or there's nothing. And if these like nans don't match up or like there's some other problem, then we can get into issues. So here we can also see that we have the proper headers. We can see the MAC address is the MAC address, the SSID is the SSID. It's not just all random. So we can see that some of these are also useful. For example, this last one, type, BLE or Wi-Fi, LTE. So some of these are literally like cell phone towers. So Wiggle Wi-Fi, very, very cool program, doesn't record clients. So it's not going to record like nearby people's cell phones and laptops and stuff, but it will record like Bluetooth devices and also like cellular towers. So just there are some trade-offs with using Wiggle Wi-Fi instead of, for example, Kismet. Kismet isn't going to pick up for example, like cell phone towers, but it will pick up other people's like laptops and smartphones. So when you're doing Wardriving, it really depends on what you want to learn. If you're interested in people's smartphones and laptops, you're going to want to go with Kismet. If you are interested in access points and Bluetooth and LTE, or maybe people like catching people running like Stingrays or something, then you would want to go with Wiggle Wi-Fi. Also, ease of use. So we can see though that if we're doing an analysis of Wi-Fi, then there's already some stuff that we would need to filter out in order to get this to work. So some of this is obviously correct, JW Marriott lobby, but some of this is not. This is just some random LTE. So I've written a little filter here, and I actually had to adapt this because this was supposed to be a Folium map thing, and now it's not working. So instead, I'm using it to create a new data frame, and I'm going to get rid of my extraneous code. I think that I can get rid of that, and it will be fine. All right, so I'm creating a new data frame called DFF, not DF, DFF. It's very different. Thank you for appreciating my Python naming conventions. Then for the amount of coordinates in the original data frame, so basically for all the different elements inside of that, we're going to go through it. And we're going to check to see if the third coordinate, or the third option within it equals Wi-Fi. So in this case, we're going to be checking to see if the type is Wi-Fi. And if it does, we are going to print it. And of course, we could also just put it into our new data frame. But in this case, I'm just going to show a very basic example of how we can start filtering this. And it should have a lot of results. So if I scroll down, there's one thing that all of these should have in common. They should all be Wi-Fi. We've now taken our data that we got from Wiggle Wi-Fi and we've specified that we only want to see Wi-Fi stuff. So let's say that this isn't the case anymore. Oh my gosh, this file is so big. So let's say instead we want Bluetooth. We want to know like where Bluetooth stuff was. Well, I can just change this and make it BLE instead. So I'm going to print. And I didn't rehearse this, but there you go. Cool. So now we have the geolocation of all this Bluetooth stuff. If I was going to bet, it was probably be, depending on when this was 2019, this is probably mostly scooters. But you'll also see like cars and other like IoT devices that will be recognizably here. You'll see like like Bluetooth trackers and other sorts of stuff just out and about. And this is a way you can filter your results that you get from Wiggle Wi-Fi to be able to see stuff that's not Wi-Fi. So if I want to do LTE, I can change that filter as well. So now I'm able to see the location of all these AT&T mobility towers in Los Angeles. So, I mean, this is a really great way to start doing projects that involve either logging the location of access points and going through and seeing like, hey, how many people have this smart security camera or this Wi-Fi security camera in Los Angeles? Well, if you have a good amount of data, you can start to filter through this and make it really easy for people to find just really whatever you want. So there have been a couple hilarious examples of this, of people geolocating like kind of like spicy or inappropriate devices, which then are broadcasting an access point that anybody can find. So this is a really interesting way of using your own data to be able to dig in and start filtering it to find something that might not be immediately obvious. So for a more advanced example, let's go ahead and switch over to Alex's screen. Sorry to surprise you, Alex. But can you explain what this giant massive code does and how it's a little bit more sophisticated than what I was showing off of just creating a filter?
So this giant mess of code is what we call the Creep Detector.
Right.
And it's what it basically does is not from Wiggle, but from Kismet, which is basically the more advanced version of Wiggle. And it's looking through this data and it's parsing for devices that match a certain sort of it's looking for
Suspicious
devices. Yeah, that's what we're looking for. So the way we were able to determine that devices were seen within a certain range of each other following your Wardriving route. And we looked at coordinates and the distance between them to determine if devices were following you over a certain path or for how long. And it's able to plot this out to map ultimately to determine where these devices were spotted, at what location, and other information you'd want to know about a nefarious device that could be tracking you.
Okay, so let me break this down for like a complete beginner so they can understand like what this is actually doing, because it is really cool. We're basically keeping track of all the devices around us as, I think we were doing this with a skateboard, right? Like you were war skating.
War skating.
So yeah, so the goal was we stick a Raspberry Pi underneath the skateboard, Alex skates around, and then we have a very, very simple thing we're looking for. Are there any Wi-Fi devices, any Wi-Fi client devices that are basically within sensor range too far away to actually be the same device? So for example, if Alex is a mile away in two different locations and we take sensor readings and we find the same cell phone is nearby him, is near his I guess, Wardriving skateboard in both times, then we know that either that is the most powerful like cell phone ever, and it's just broadcasting so strongly that it can be seen from a mile away, which is very unlikely, or that has followed him. So what this is doing is it's keeping track of all these relationships and saying, hey, have I seen this device before? And if it has seen that device before, it checks to see if it has been a reasonable distance between the last sighting. So if it is a reasonable distance, like maybe it's only like 50 feet from the last time we saw this device, well, that sounds reasonable. But if it's like a half mile or something longer, then this will actually mark the location where there's a situation where suddenly maybe someone's following you or you're seeing the same device in a place where it shouldn't be. It's basically too far away from the last sighting to be a coincidence. So this is so cool because instead of looking for access points and just logging things that are broadcasting, we're starting to get creepy. We're starting to like look at people's cell phones, and we would be able to conceivably detect somebody who was following us around or didn't want us to know they were following us using this technique, because we're really just comparing relationships between devices we've seen. We're just having Python ask the same question over and over. Have I seen this device before? And if I have, is the last distance I saw this device, or is the last sighting I saw this device a reasonable distance from where I am now? And if the answer is no, then we're going to assume that there's a creep nearby. So can you walk over kind of like what the cells of this do? Because this is broken up into individual kind of like blocks of code that run bit by bit. And could you maybe enlarge your screen just a little bit so it's easier to see the text?
Yeah, do you want me to zoom in more?
Well, just control +++ is finally fine.
Okie dokie. Oh gosh.
Yeah. Yeah, no, that's good.
Okay. So
just do it for the people that were partially blind.
Okay, so this first cell here is just basic imports. So we're importing libraries like pandas, which handles data frames. We have an XML parsing library because the file that Kismet spits out at us is a net XML file, and it's terrible. We have to parse this by hand, which is much more complicated than the CSV that Wiggle gives us.
Right.
We
One
also
thing
have,
to mention here as well is there's an old version and a new version of Kismet, and the new version of Kismet spits out like a database file, which I guess you can
yeah,
convert to something else, but it like kind of sucks to work with. The old version of Kismet, which is command line only, spits out this not perfect but still workable file that you can parse by hand and isn't that difficult. So if you're working on a project like this and you're getting frustrated, we found out that the older version of Kismet seems to be the better one to work with.
yeah, still nevertheless frustrating though.
Yes.
Then, okay, so the other library we have Folium, which we'll be using for plotting the creeps on the map. So that just basically imports everything. This next line here, what does that even do? Okay, this is a function that I wrote that takes this list here, macvendors.txt, and this is just a file that I pulled from the internet that has a list of Mac vendors and their OUI, which is the first 3 octets of a MAC address. And this allows us to associate certain possible vendors. So we could see if there's Samsung devices, Apple devices, what kind of things would be in the area.
I really like this because it's also a great example of how you can, in Google Colab, import another data source and start using it with what you already have. So in this case, you're combining 2 data sources already. You're having your data that you got from Kismet, and you also have your list of MAC address vendors, so you can compare them and get matches between them. So that's another thing that's really great about Collab.
So this next cell is another little prerequisite thing I had to set up here. It's a function that finds the distance between 2 GPS coordinates. And later on in the code, we use this to determine the maximum distance or threshold that wins if it's a creep or not. And that's referred to as the Haversine formula. It's some crazy stuff, crazy math I don't understand.
Cool. So this is also where you are setting like the limit for when it's not reasonable for a device to be seen in 2 places, right?
Actually, I have that a little later on in the code. This is just the function setup, but we have the threshold set down here.
Cool.
So I think like a quarter mile.
Okay,
or
cool.
Something. Yeah.
So that's just getting the raw distance then.
That's all this returns, which is this crazy mathematical formula here that I searched up. The following cell, thank God I have documentation here. It's a net XML parser that creates array data for Wi-Fi devices. So I think what this is doing is it compiles together all of the raw devices into a big array that I think down here is called station list. And then the following cell after that just parses through the station list, and it separates it into wireless networks and clients, so we can differentiate whether or not the creeps that we spotted are client devices. So like if someone had a cell phone, for instance, or if it's just a wireless access point, so like a router or something like that.
Right. So in this particular case, we are only interested in clients, and we're not really interested in WAPs, because that's not in this case what we're seeking out. Unlike the on average day. So while we might be more interested in wireless access points when we are like just looking to compare maybe IoT devices or cameras, in this case you are filtering all that stuff out and sticking purely to clients. No WAPs allowed.
Okay, so as denoted here starts. So I started by declaring the threshold, which is set to 0.2 miles. And it basically just parses through, well, sorts through the list that we assembled, station list. And it applies the Haversine formula, which is to determine the distance between any consecutive or any GPS coordinates that we choose to feed to this formula. And it determines whether or not it's within the threshold of 0.2 miles. And if that's so, then it'll append devices spotted within that threshold to another list that we call creeps. So the following little chunk of code here will look over this creep list and it'll parse out duplicates because for some reason, Kismet had a tendency to log devices more than once, and I didn't want that to be popping up in our data table. And yeah, it basically just glosses over and removes any anomalies that we don't necessarily hear. And then finally, the data frame just prints that.
Oh, one thing I was going to mention is for people that are just getting started with this, probably the most frustrating thing about working with Jupyter Notebook or Google Colab is cleaning up your data or getting errors because you either have null values or like you have duplicates or something like that. So one thing to expect, and one thing I just wanted to point out from Alex's code that like is just critical, is you're going to be cleaning up your data and finding that there's like some weird outliers that mess up what you're doing. So cleaning up your data is one of the first parts of doing any like kind of big data project, which this kind of is. So you'll notice that throughout different parts of this, Alex will have different lines of code that are just getting rid of results that are bad or otherwise cleaning up anomalous results. And this is really, really helpful for making sure, for example, you don't get a line of results that are going into, the South Pole, which happens. Just because of some error or something like that, and cleaning up those results so that they get out of your data and you can get something that's useful is really important.
Yeah, definitely. I think more than probably 90% of my code is just parsing through data and looking for disgusting anomalies. Like, look at this code. It's completely terrible. And there's just arbitrary variables here to set thresholds for things to parse out and look for weird devices that pop up.
Yeah. So getting this working is often getting a bunch of errors and figuring out what data is polluting the rest of your results. So just realize a lot of this kind of looks like a bunch of code, but much of it is just making sure that we're getting rid of any results that pop up. And this could be as simple as just somebody that doesn't have a Wi-Fi network name and your program crashes because it's expecting one. So
yeah. So you can see after the data frame got printed out, I think this was the test device that we'd set up called Creeper, which is like an ESP82 point. But kind of, yeah. The control access point. But I don't know why these other ones popped up. I guess we were just too close to them or the threshold was too low. Because we didn't really go that far on the Wardriving route.
That's true. So there's a couple other things that also might account for that. So for one, there were other people in the car. So when we went, there might be other people's cell phones that were with us. And then also, so we did, so for this particular test, the way that we did it was we wanted to see if this could detect access points. So if someone had like a hotspot on or something, if we could catch them, that's easy. But we also wanted to see if we could catch someone who wasn't using an access point, so clients as well. So this is checking for both. So the creeper result is us logging successfully that we've seen this access point in two different places, and that's suspicious. And then we're also logging that we've seen these devices in two different places, and that's suspicious. So there's two different results that are being displayed here. We're showing suspicious access points, and we're showing suspicious clients all in the same view.
Yeah. So now that we have creeps assembled, the next thing is just to plot them out, which the following code basically just handles mapping stuff. So unfortunately, for some reason, Kismet jumbles together all of the clients, all the networks together in no particular order. So since they weren't consecutive, I had to find a way to be able to plot our route without it just being a whole jumbled mess. So I wrote this pretty crummy algorithm here that basically determines what a path could look like by looking at the distance between GPS coordinates and sorting through the whole list of assembled creeps, finding the closest distance between them, and it uses that to determine whether or not that could be a viable. So yeah, there's this whole jumble of arbitrary. And then finally, this last cell here just plots the little creep icons that you see here.
Okay, cool. So
And you can toggle them, yeah.
So included in this is the ability to, with that algorithm, as you mentioned, actually start to see what paths one might have been taking while they were following you. So we're not even just necessarily seeing
Right.
things just plotted randomly. We're seeing what looks like the most likely point at which you are being followed by this particular device.
Right. I think if I...
That's really cool.
Yeah. Wonder if I can change this parameter here to show what it looks like unsorted. I'm gonna run that. Yeah, so we have...
Whoa.
Okay, that's not terrible. You can see here, there's like a jump in our path. That's only running the out like 3 times. It came out like a jumbled mess of spaghetti. Yeah, so now you can see our path is altered again. So I was just randomly tweaking the values.
It's going through like a bunch of like buildings now.
Yeah. But yeah.
You can also see there's a couple of clusters where it looks like there was a lot of hits. There's a couple that are like kind of like vague, and then there's a couple points where it definitely looks like there was more than a couple detections. What does it look like when, after it loads, of course, when you click on the results? Or on one of the icons?
Like the individual icons? That just shows you the MAC address for the device.
So then if you wanted to go on to...
that.
Oh yeah, sorry. I was gonna say, like, if you wanted to go on to like copy that and then use it as a filter, the way I was using it in my program to maybe see all the different results that were concerning that device, like all the different places it's been spotted, you could start doing some follow-up with just learning a bit more about the device you identified as a creep.
And it's logged, of course, other information about the device, like, well, besides the BSSID, we also have, holy crap. You can see where it was spotted, what times it was spotted, manufacturer, encryption of the device, ESSID, stuff like that.
All right, so I think this is a pretty good like place to round out our brief introduction to just getting started with using this data. But I want to just fire off your imagination towards a couple other things you could do. If you wanted to find every vulnerable access point in your area just by driving around and running a couple Python commands, this will do it. If you wanted to find every Wi-Fi security camera of a particular manufacturer, this will do it. And if you wanted to find, for example, as Alex showed, anybody who might be following you by using a different program, in this case Kismet, to record information and then look for relationships about devices that are displaying suspicious behavior, then you can do that too. So Wardriving data, while the concept of Wardriving has been along for a long time, is getting more and more useful by the day because tools like Google Colab allow you to just throw this into a very easy to use, very, very simple interface and start running simple basic Python in order to filter through the data, plot it, and even be able to map it, as Alex was able to show. But even if you don't want to go that far, you can still take this data and throw it on a map just using the simple custom Google map that I was showing off too, and that can allow you to see the results that you get without needing to do any of this fancy coding stuff. So thank you, by the way, Alex, for showing me the Google mapping stuff, because I didn't know that that was probably the easiest way to start plotting this data.
Yeah, of course.
So if somebody wanted to get started doing this, or if they wanted to take a look at your code, what's the best way to follow your Creep Detector project?
You could either check out the Creep Detector project on the GitHub. I actually think it's on your GitHub, right? Or is it on mine? I don't know.
I don't even remember. You built a better website for it, though.
Yeah, I did. Okay, you can find it on my website, which is alexlynd.com/project/creep detector. Or you could also check it out on my YouTube channel, which is just my name, Alex Lynd.
So if you guys like this episode and you want us to go more into analyzing Wi-Fi data, we would love to show off some more stuff you can do in Google Colab and make it easy for you guys to follow along. So please let us know in the comments. Thank you for watching us today. And of course, if you like this content, you can check out some of the other great stuff that Varonis does on the Varonis brand channel. Our sometimes host Killian is also doing the threat update, which is a great way to find out what real companies are up against every day when it comes to malware attackers and other sorts of cyber threats. So thank you so much, Alex, for joining us today. Hopefully we'll have you back on again soon. And yeah, we'll see you guys next time. Bye.